Okay, we are revising Emaths Trigo now. Now, Emaths Trigo is very straightforward. You either have a right angle triangle or non-right angle triangle. Okay, so if it's a right angle triangle, you think of Pythagoras theorem. Pythagoras theorem cannot make it, then you tuakaso. Tuakaso cannot, then you use half times base times height. Okay, now if it's not a right angle triangle, okay, then you think of sine rule. Sine rule is just something over something equals something over something. If this is an angle, this must be an angle. That means sine of an angle equals sine of the other angle, then over the the length on the opposite side. Okay, now these two formulae, they are actually found in your formula sheet, so don't forget. If you forget how to if you forget the formula, you can just refer to the formula sheet. And then this one, the way that we learn is the victim, and then these are the two arms, right? And then this is the angle. Okay, we're going to discuss how to use all this in this particular video. Now, if the area, if the triangle is not a right angle triangle, then you can use half AB sine C. But most of the time, these two are used concurrently. Now, what do I mean by use concurrently? Meaning to say that they may ask you to find the shortest distance. Okay, surely they will ask you find shortest distance from a certain point to a certain line. Now, the shortest distance, of course, we know is the perpendicular distance, right? Okay, so what you need to do is, of course, you need to know the area of this triangle first. Okay, normally, you see the half, half times base times height is the area of this triangle using half times base. This is the base. Okay, normally you can find this base using either sine rule or cosine rule. Alright, then after that, you equate it to half AB sine C. You would know the base, you only don't know the length here. Okay, and this half AB sine C is like the monster like that. So most of the time they would, maybe you know this angle, and then you know this length, so you can use half AB sine C. Or if you know this length, this angle, then you know this, then it's half AB sine C. Okay, so it depends on what you are given. There's no fixed rule. Okay, now another way, once I know all this, right, I can make this a subject, and then I can find the answer already. Okay, another way to find this length is this. Let's say you know that this is, let's say, 93. Okay, and then you know this is, let's say, 45. There, right angle triangle, what? So you can use this is opposite, right? Opposite, and this is hypotenuse, right? So what is O and H? O and H is sine, right? So you can use sine to find this one also. Okay, similarly, if I want to find this length for me, right? If I want to find this length for me, if I know this angle and I know this length, isn't this the adjacent? Isn't this the hypotenuse? We are not interested in the opposite. Okay, A and H, you can use cosine of this angle equals to A over H. So that's how you can find this length here lah. Okay, so it's very flexible, meaning to say you see, once you have a right angle triangle, you can use Pythagoras, tuakaso, or this one. Non-right angle triangle, then you use sine rule, cosine rule, or this one. Okay, so I hope you are clear about this. You must be very clear about this, then it'll be very easy. Okay, now the other thing you need to know is how to convert from hours to minutes to seconds. They may just ask you to do one of these, or they may just ask you to do one of these. So let's say you calculate using DST. You need to know this formula also. So let's say you calculate the time, right? Then the distance over the time, then you get let's say 2.1652 hours. Okay, then they ask you to change this to minutes, or the nearest minute. So nearest minute means what? Nearest minute, you can still have 2 hours. Okay, but you need to say how many minutes this is. So it's very simple. To change from hours to minutes, you times 60, right? So you take 0.1652, you times 60, and then you get a certain answer. The nearest minute is, okay, I don't know where my calculator is. Okay, the nearest minute is, let's say you have let's see this, Let's say you have 8.234 whatever, right? Or 18, let's say 18, 18.234 whatever, then it'll be 18 minutes. That means 2 hours, 18 minutes. Okay, so that's how you do the conversion. Alright, okay, now bearing is also under this trigo. Trigo is a big topic. So bearing, very simple. You always start from north, okay, or you start from north, or you say look north. So if they say bearing of P from Q means you are at Q, you stand at Q, you look north, okay, look north, you turn clockwise until you see P. Alright, so this is the angle that they want. But the other thing very important about bearing is that it must minimally have 3 digits. So if it's like that, right, then it's 0. If let's say it's 60 degrees exactly, then it's 060. Okay, but if let's say it's 60.1, you calculated already, then it's not an exact value. Exact value means like that. Let's say exact value, right, you must leave your answer like that. If it's not exact value, you leave in 1 dp. Okay, so that's all for bearing. Bearing, they will combine with all this lah. So you need to know. Okay, then the other thing which you learn in the lower sec, right, is angle of elevation, angle of depression. Very simple. You draw a horizontal, right? This is your angle of elevation when you look up. Okay, so after that you can use your tuakaso. Same here, you can use your tuakaso. Alright. Okay, now let's go straight to a question. Okay, let's say you're given this. Okay, you have all these with you in soft copy. Okay, given this, and then you say A, B, C, D are points on level ground. That means all these are points. All these are points. And this north, right? The north, take note, can point here, straight ahead, or it can point to the left, to the right. It can point whatever. So wherever the north points to, you must follow. Okay. B is due west. Now whenever you see this due west, okay, I didn't write here, but due east lah, due west lah. What they're trying to tell you, right, is to look out for 90 degrees. Okay, you look out for 90 degrees. So in this case, B is due north, south, east, west. You see, north, south, east, west. So due west of A. That means they're trying to tell you this is 90. Alright, so very importantly, when you do this trigo question, right, you must update your diagram. If you don't update your diagram, meaning, what do I mean by update your diagram? Update your diagram means whatever you read here, you know already, you update here, you write here. Or whatever they ask you to find already after you found the answer, write here. Update your diagram so that a picture tells 1,000 words and you can easily solve the question after that. Okay, now let's see. This one I know already. This one 97, did they label? Yes, they label. Bearing, this one not labeled, so you must be careful. You see, all these are labeled, but this one not labeled. So you see, bearing of C from B. Bearing of C from B. From B means I'm at B. Okay, I look north. Look north means look parallel to it. Okay, it doesn't mean look north. No, look north means like that. Alright, then what happens? I want bearing of B from C from B, right? From B, I'm at B already. I look north already. I want to turn until I see the C. So it's this whole thing that I want. But just now, I already know from here that this is 90, and north, they're parallel, right? They're parallel. So this must be 90 also. Which means that if I am able to find this angle, if I'm able to find this angle, okay, somehow from this triangle, then I win already, because I can just take 90 plus this angle, and that'll be the bearing that I want, right? So that is what I'm going to do. How do I do this? You take a look, then you see that are you able to find what you call that? Oh, sorry, they ask you to find, sorry, bearing of C from B. They didn't ask you to find the bearing. They give you the bearing. They tell you this is 122. So it is 122. This whole thing is 122, right? 122, and then this is 90. Minus 90. So isn't this 32? This one here is 32, right? So that's what they are trying to tell you. Alright? So this is the important information here that they've given you. Now calculate angle CAD. CAD. Okay? CAD here. Can you see that this one is the monster? The victim is here. Okay? So how do we apply this? Now, if you know the formula very well, you can just straight away apply like that. But if you don't know, right, then you do what? You do like that. The victim is alone, right? Okay, then my pen all disappeared. Wait. Victim is alone, then is equals to something like Pythagoras. Then minus 2 times of this times this. Okay, then cosine of this angle, which is what you want, right? CAD. Then now you see, now this whole thing change place with this fella. Then this will become positive, right? This one and this one remains here. Okay, then minus this fella. Correct? Then you do step by step. Isn't this whole thing you divide by this? That's why it's over here. Correct? This thing gone already. And then this one, I just want to find this angle. So I don't want the cos here. So it's just CAD equals cosine inverse of this. There. That's why you get this. Alright, so if you know this, very good. You do straight away. If you don't know, you do this. Now you must either, okay, in this case they put 2 for 6 7 SF. Actually 5 SF enough already. Then you round off, okay? You round off, and for angles in degrees, it must be 1 dp, not 3 SF. If you put 3 SF here, then wrong already. Okay? Now find the bearing of A from D. If we are done with this already, what must we do? We must update here, meaning that 75.870, okay, 5 SF will do. You update here. Then now they ask you to find the bearing of A from D. From D means you stand at D, you look out for A. You stand at D, you look north, so you must draw your own north line. Draw your own north line. Then you turn clockwise. Turn until you see what? CA. You turn until you see A. Okay? Now, how do we do this part here? Okay, actually we need the diagram. Can you see that this BAC, BAC, right? You can find BAC by taking 180 minus this. So that will give you 77 degrees. Correct? Then now how do I find bearing of A from this thing here? Okay, what you do is can you see that if this is 77 point something, okay, 77 point something, then this is 75 point something. Can you see that this plus this, if I minus off this 90, that will give me this, and this this is actually equals to this. Correct? Alternate angles. Then you can take 360 minus this. That will give you the bearing, which is 297.1 degrees. Okay? And now they ask you to find the area of ACD. ACD here. How to find? Oh, once you know this, you can use half. See, half AB sine C. There. Half AB sine C. Sure come out one. Okay, so that's all. That's all there is to it. Now, this area, you bear in mind that you know this area already, because the next part they will need you to find this area. Now, 3SF means 1, 2, 3. So you cut off here. So 4,000 plus cannot be 499, right? It must be 4990, so that is still in the thousands. And then write your unit. Okay. Now the next last part is normally always like that one. Okay, they tell you a vertical post stands at D. Now I recommended to some of you to use a different color pen. Now in your question paper, right, it'll be black color. You can use a different color pen to represent things that are above ground, in the air. Okay, above ground. So a vertical flag post stands at D. You can draw like that. To tell yourself, right, that this red thing is not flat on the floor. It's actually standing like that. Okay, or you can use your pen if you're more comfortable. But actually, you see how whether you understand or not first. The angle elevation of the top of the flagpole from A is this. Meaning to say, when I'm at A, I look straight. There will be this line on the floor, right? But I look up. Don't you agree that this pen is perpendicular to this line? So isn't this 90 degrees? Okay? If you can't see, right? If you can't see, you draw another diagram. So A is here, D is on the floor. Okay? Let's say you call this the top. Then isn't this right angle? And isn't this 106? And you look up, and it's 17.2, right? 17.2. So opposite over adjacent, you use what? Tangent. So tangent of 17.2 equals to the height over the, we call this the height, height over the 106. Then you cross multiply, then you get this already, then here. That's all. Okay. Now they now ask you for what did they ask? Calculate the angle of elevation at the point AC and furthest away. Furthest away from D. Now, if they say nearest, it'll be this 90 degrees, right? But if it's furthest, then where would it be? It will be here. The longer away I am from here, you see this is only 106, this is 125. So you use this fella, meaning to say, now you know that this is, just now we calculate the height, is 32. That's why I say you must update the diagram, okay? Must update the diagram, okay? You can draw like that, You see the red tells us, right, that is in the air, This is on the floor, in the air, okay? Then they want this angle. Isn't this, let's say you call it theta, isn't it tangent inverse? Yeah, tangent theta equals opposite over adjacent, right? There. After that, you go and tangent inverse, then find the answer, So that's it. Very simple, trigo. Okay. So go and score for trigo. All right. I have other examples here. Okay, I don't know whether you want me to go through. No? Okay, I just quickly go through. Just to tell you, right? the fence is supposed to be built along PR, right? Then you see, this is the monster law. The monster is here with the two arms, right? Then this is the tongue, and that's what you want to find. So this is the normal cosine rule that you need to use. Okay, then for this particular question, just want to highlight one thing to you, okay? You must read the question. You don't read the question, gone case. Okay, so PQIs is on the floor. This one 70, this one like that, this one like that, like that. Okay, now important thing is this. PSR is obtuse. What is obtuse? Now a cube is like that. QQ angle. Then obtuse, right, is like the other side. One straight line, right? This is acute. This is obtuse. Okay? Reflex is like this. Okay? Yeah. So they tell you this. Sorry. They tell you this. There must be a reason one. Okay? Later you will see why. Okay, now. Bearing of S from R. S. The bearing from R. From R means you stand at R, you look north. You see, I stand at R, look north, turn clockwise until you see S, right? So this whole thing is 337.4. Okay? Now, this part here, they already tell you it's 337.4, so you just label it 337.4. There must be a reason why they give you this, okay? Then you just check the rest. Oh, this one is 38.7, okay? This one is 57.3, okay? Then the rest all given, Okay, now, what do they want from us? We already done part A, very simple. Now they want the bearing of S from P. Okay? Bearing of S from P. Where is that? Bearing of S from P. Meaning, I am standing from P means I'm at P, right? Then I look north, but I must draw the north line first. Draw parallel to this, Then I turn until I see S. Okay, S, right? So it's this one that they want. How do I find this? Very, very simple. This is north also, right? If I can find this, okay? If I can find this one I already know, is it? This one I already know. So, and if I can find this, then I win already. Because these two are parallel. This one parallel this one, right? So the interior angles, this plus this plus this plus this must be 180, right? So I already know this, I already know this. Can I find this? Yes, because this is the whole round is 360, right? This is 337.4. So this must be what? This must be 22.6. So you see, I know this, I know this, I just need to find this. Am I able to find this? Can or not? Can, right? Okay, so you can find that one. Because then you say, how to find? I don't know this, I don't know this. You see, just now I already told you to label, you never label, you see. That's why you don't know. You don't know that you know already, you see. You must label the diagram. You already know this, so you must label. 76.667. Now you see, I got a friend, and I got a friend. Once I know this, I can take 180 minus this, I can find this already. Then you take 180 minus this, minus this, minus this, you'll be able to get this. Okay? So that's the whole idea. Now, you must be very careful. When you use the friend rule, sign PSR, right? PSR. This one you must take note, must take note, okay? May come out, This PSR, right? Because they are testing you on obtuse. What is obtuse angle, okay? Obtuse what? More than 90 degrees, Okay. But you go and try. Ladies and gentlemen, everybody go and try, you sine of this over this, that's this one, right? Equals to sine of this angle over the friend. Okay? You will find that your angle, you will get 57.88 whatever. Then you say, how are you talking about? You will find that your PSR, right? If you press your calculator, sine inverse of this, must be degree mode, okay? You will find that your answer is 57.878. Okay? You must reject this. Why reject? Because PSR is obtuse, so you must take 180 minus this. Then get this. So your this one is 122.122. Very nice number. Okay? Then you take 180 minus this, you will be able to get this, which is 19.178. Then the whole bearing, right, is just 180 minus this. That's it. Finish. Okay? Meaning, you want to find this is 180 minus this, then you get this already. Okay? Finish. Okay, then the last part, right? There, just use half AB sin C. Okay, I won't go through. Okay, now angle of elevation, depression. This one you use this to help you. You go and a water tower is to be built at R. Okay, here the base of a vertical lamp LQ is at Q. What are they talking about? That means they're trying to say, right, there's this vertical lamp LQ. The Q is the base. That means this is the base. Then L is the top. They're just trying to tell you this L, this Q. Okay? Then the angle elevation of the top of the water tower from Q is 16. The angle elevation of the top of the water tower. Water tower, where is it? It is here. That means this part here, the top, right? This is the horizontal line. When I look up from here, see, I'm drawing all in red. When I look up from here, it's 16. Okay? And the angle of depression of L from the top of the water tower is 11. Okay, so you see whether you understand. The angle elevation of the top of the water tower from Q. Oh, sorry, here. Here is 16. Sorry. Then here you draw a horizontal. When you're at the angle of depression of L, that means when I will try to look at this point from the top of the tower, water, then I look, right, it's 11. So this must be 11 also, using the Z alternate angles. Okay, so they want me to find the height of LQ. So how to find? Very simple. You just find using Tuakaso. Okay, you go and take a look. So this is application of angle of elevation and depression. Alright. Okay, it's all with you in your soft copy. Okay, I think still got one more. One more, you go and look at it. I think, okay, this kind, right, everybody, ladies and gentlemen, when they ask you to show, you must show the 5SF first, then you show the original, okay? Otherwise, they won't give you the marks. Okay, yeah, I think the rest, oh yeah, I want to go through with you. For 3D questions, okay? Remember 3-dimensional questions. What is the strategy you must use that will help you to score full marks? You look out for right angle triangles. Once you can find the right angle triangles, you win already. Most of the time, it is right angle triangle, but sometimes it is not. So if it's not, then you use the sine rule, cosine rule, and this. Okay? But most of the time, it's Tuakaso and Pythagoras. You can solve the question already. So let me just give you one example. Okay, the diagram below shows a cuboid. This is a cuboid. Okay, AB equals to 4. So on and so forth. M is the midpoint. This M is the midpoint is important. That means this length and this length, they are the same. Okay, you mark it down. That means this is 6, this is 6. Okay. Then M is okay. M is the midpoint of AE. Yeah, I found it. Okay, so angle of elevation of G from M. Wow, angle of elevation of G from M. So I draw a horizontal line. Okay, this is my horizontal line, and this is like my angle of elevation, right? And then you see where's the right angle triangle? I told you already. Once you can see that, that means when you see from this side, you now take your eraser or what, anything that is like a cuboid, then you see from this side, right? Of course, it's a right angle triangle, because I draw horizontal to it, and then this line is perpendicular to it, right? Okay, then you see just now I label here 6, right? So isn't this 6? So how do I continue? Am I able to find, see, once I know this one, okay, if I know this one, I can use opposite over adjacent. That means tangent, then I can find the answer already, lor. But how do I find this line? This line is actually, you see, I draw another line here. Don't you agree that when you look from the top, this is a right angle triangle, right? Sorry, this is a 90 90 90 90 rectangular base, you see. So this must be a right angle triangle, and from here you can find 5, 3, 4, 5. That's how you get all these, and then you can find the answer already. So 3D, very simple. Okay, look out for right angle triangle. Okay, bye bye.